worldwide lockdown. And, so our hearts and thoughts go out to everyone who is suffering most from this crisis, physically, economically, or emotionally. So my name is Franz Fischer. I'm the director of the Venice Center for Digital and Public Humanities, and we are the center has been established in June last year, and we are running this seminar series since September last year, and this will continue until the summer, and then continue also in the next academic year. We do a lot of other activities. There is supposed to be a summer school this year, but this is all in doubt. So we have to make decisions in the course of April if we are able to actually carry out an international summer school in Venice in the summer or early autumn, or if we have to cancel it or transpose it into the next year. So these are all open decisions. You are all aware of the situation. In September, we will start a Master on Digital and Public Humanities at Venice University, and we will publish this and advertise this widely. We are doing a lot of many workshops on specific topics in the fields of digital textual scholarship, digital and public history, digital and public art history, and digital cultural heritage, and digital GLAM sector. So this is our first online seminar, and this will be a test case for then how to decide how to carry on with the series. The next one will be also widely advertised on the channels that have been successful, obviously, to reach out to you. With Rodolfo Del Monte in the next week, you will talk about poetry and computer speech, analyzing and reading Elizabethan and modern poets with Sparsa. Then the week after, we will do the seminar that has been planned for in February by Sarah Tonelli from the Kessler Foundation on current studies on cyberbullying and Islamophobia, building tools and data set to detect online speech. I would like to thank you very much to my team, especially to Federico Boschetti, Tiziana Mancinelli, Linda Spinazze, and Paolo Monella, who are organizing this seminar series, and also the technical support for this online version of the seminar series. Feedback is most welcome, so you can give feedback via email or put it in the chat or contact us individually. So whatever you would like to suggest to improve actually this activity is most welcome. The slides of all presentations and the upcoming presentation will be published and made accessible online on our GitHub repository. And as regards the presentation by Daniel Fusi, to whom I will introduce you now, there will be also the code and of the software he's currently developing. We're doing a record of this seminar, and this will be also published on our YouTube channel. So please note our privacy notification at the beginning of the slideshow of Daniele Fusi, and so be aware that all contributions to the discussion will then be visible online on the YouTube video. Daniele Fusi, who is talking to us in a minute, studied history of the Greek language at La Sapienza, University of Rome, and holds a PhD in Greek and Latin philology from the Classics Department of the University of Genoa. He has been working for many years as a professional software developer and IT consultant, and since 2007 as a contract professor for digital humanities at La Sapienza. His scholarly interests are centered around digital textual scholarship, and he has been working mainly on software applications and systems for linguistics, metrics, lexicography, epigraphy, and digital archives. He developed full-stack solutions for digital publishers in both commercial and academic fields, such as Sanichelli or Microsoft, and several universities and academic institutions, including Accademia della Crusca. Since September 2019, he has been working as a research fellow at the Venice Center for Digital and Public Humanities, together with our team on a technical research infrastructure for the center and our department, and more specifically on Cadmus, a general purpose and modular content editing alternative for complex models. And this is also the title of his presentation here today. And yeah, so there will be a discussion after Daniele's presentation, and we will give further instructions then how to guide through the discussions after the presentation of Daniele Fusi. So the floor is open, the virtual floor is open for your presentation. You will open your slides on the Meet screen, I suppose. So let's hope this works. If there are some difficulties, I'm sure we will be able to fix them as quickly as possible. Okay, I can't hear anything. Daniele, can you start, or do you have problems with the microphone?
Can you hear me now?
Yeah, we can hear you. I can hear you at least. Yeah, okay.
Are you seeing the slides?
Yes.
Okay, so let's start. In this discussion, I'd like to sow a seed of doubt about issues emerging in producing certain types of digital content. And I hope that starting to think about these issues and their theoretical implications can help in finding new ways of doing our scholarly work, just as the mythological Cadmus did when sowing his parsley. So the typical approach in producing digital text editions is what we can call the book paradigm, where the text is the only actor, and from start to end, it just flows through several steps. We start from paper, have it acquired via OCR software, mark it up with XML, and finally publish it, transforming XML into other technologies. Now, data here is essentially text and markup, that is text with metatextual role inserted into the plain text document. So we start with printed text, get a plain digital text, manually add markup to represent document structure, like text divisions, headers, verses, etc. And all this is implicitly organized into a single hierarchical structure, and this is our data tree, as you all know. Now, this book paradigm has a lot of benefits, and it's document-centric, which is a very familiar mental model, and is ideal for representing historical documents. It is well fit to text-oriented content creation habits, because we just have to type text in a file, and it has a high portability and lifespan, because it's just plain text. And this also implies that we have no specific software requirement, and essential publishing technologies are already in the XML realm. And the fact that one document is the unique source of all data makes it for, also a great format for archiving and exchange. Yet, it also has its drawbacks, mostly connected with markup and a single structure. First, all our data must be physically stored as markup, that is, elements and attributes, of course, in a document file. And this implies that we can change any data, textual or not, without touching the whole document. And second, and more important, all data is laid on the unique document structure, our tree, and any additional structure must be fitted into this unique one. So when adding new content, the existing structure schema must be altered, introducing new attributes and elements, thus growing in complexity and laxitude. And the design of new data models is biased by the requirement to have them physically stored as markup, which must fit into an existing tree. A single catch-all structure here tends somehow to laxitude and ambiguity. That is, the schema allows for a huge number of possibilities. And when we find ourselves in need of processing our documents for whatever purpose, we must often face this question, that is, in a specific set of documents, what is effectively inside what? And to find an answer, usually we have to scan all the documents and deduce a tree from them. This graph, for instance, is a report produced by such a software tool of mine, and you can see all the elements and attributes with their positions, frequency, text nodes, terminal and empty elements. And we can also observe unpredictable nestings, even recursive, like an emphasis inside another one, a note inside another one, or even emphasis inside a note, which in turn is inside another note, and so forth. So while the schema virtually allows any nestings, the actual documents only present some of them. And to discover this subset, we have to scan them. And this is an issue when trying to provide a general purpose software solutions in many cases. And second, another question is, what is the specific meaning of elements and attributes? Because often in a lax schema, elements and their locations are so prone to interpretation that we must ask the document creators themselves about the details. Several elements can be used in very different ways with specialized meanings. For instance, in these documents, the text reporting a variant is split into 4 optional sections, and each is defined by a special combination of an element and an attribute, as listed here in these 5 points. And it is all compliant with TAI, yet it's not defined in TAI. And these elements so gets charged with an additional specific meaning, which is outside the schema. Now, in most cases, this just works fine, as just works TAI. Let's see how it deals with increasing complexity. We can start with critical texts and their apparatus. In TAI, as you know, the critical apparatus is essentially a repository of variants, and one core aspect here is linking variants to their text. More generally, this means attaching new metadata to the existing tree. So in a TAI line like this, we want to encode the mutantibus variant for turbantibus. And as you know, the apparatus model branches from a root up element and has a lemma, a number of variant readings, and so forth. And this whole branch must somehow be attached to the text tree. And there are different linking methods for this. The simplest one is location referenced, as it's known. And here we just embed the app element inside the text element, in this case, L, our verse. And this comes at the price of merging 2 different structures in our single tree. And each of them adds complexity to the other, because the L model is somehow polluted by the app model as they are mingled together. And the link between mutantibus and turbantibus in this model remains implicit for human readers only, because in this markup there is nothing which tells us that mutantibus refers exactly to turbantibus in the parent element. An implicit link, just like that on a paper apparatus, is not acceptable in a digital product. And so most used method here is rather parallel segmentation. And in our sample, to make an explicit link, we split the sample text into 3 parallel chunks, where one is the app element, which contains 2 different variants. So we had the first part of this line, Suave Marivagnon, which is our first chunk. Then we add another chunk, which is represented by the up element with the two alternative readings, turbantibus and mutantibus. And then we have the third part of the line, Ecura Ventis, which is our third chunk. Of course, this forces us to split a unitary text, the verse, because of its tradition, and of course can be applied only in line, whence somehow the pollution of the model, and it's somewhat fragile as it blows out as soon as text can't be segmented in parallel. And also it's easy to conflict with other inline structures. We can easily show how quickly this method may require hackish solutions. Let's start, for instance, from the preceding sample. Here we have 3 chunks to allow for the mutantibus variant. Now, let's pretend that we also had a fake variant where Magno and Ventis are swapped. The corresponding XML code might be like this. We still have the 3 chunks for mutantibus, and then we wrap these chunks inside another chunk A and duplicate the whole line in chunk B, making it parallel to A. This sort of hack is the only way to represent these 2 different variants in the same line. Yet, this implies that the whole line has to be duplicated to make it parallel to the other text version. And we have an up element nested inside another up element to represent the single word variant as before, turbantibus and mutantibus. And this introduces a lot of complexity and laxitude up to recursivity up inside another up in the schema. And why does it happen? It's just that elements like L belong to a structure which is different from that connected with elements like up. We are really dealing with 2 structures merged into one tree. On one side, different structures call for distinct models. We have the verse, which is a regulation of some linguistic features of a text. And its model should include things like design, number and type of units, syllable boundaries and features, word ends, distributions, loss compliance, etc. On the other side, we have the text tradition, which, tough connected, is completely another different story. And yet, in a single tree, they must be merged, making it more complex and lax. So, in this case, we may even have a recursive schema where L and up may include each other according to which is longer. For instance, if the text span for apparatus is less than the verse span, we find up inside L. If instead we have a text span for the apparatus which is greater than the verse span, we have L inside up. As we have seen, this method requires a systematic refactoring of the text tree to split it into parallel chunks. And this makes it very complex, or can even be impossible. And where segmentation is not possible or inlining is not an option, right because of its added complexity, the ultimate solution is the double endpoint attached method. Here, the conflict between 2 structures into one tree is resolved by splitting the trees. So we have 2 distinct documents, one with the text and another dependent one with the apparatus. To realize this connection, we must then insert anchor elements to delimit the target text. Here we have a from anchor and a to anchor, which define the boundaries of the text, that is, turbantibus. And each of these anchors has its own identifier attribute. Finally, in the apparatus document, we must link the up element to this text by specifying these identifiers. Sorry, I'm getting a chat. Is there anything I should read just now? Okay, no, just continuing. In the apparatus documents, I was saying, we must link the app element to this text by specifying these identifiers, keeping these two documents in sync. And this is not that easy. So our first issue is just that this method usually is too complex to be manually used. And also maintenance is somewhat difficult because we have to keep in sync two distinct documents. And we still have to pollute the text to ensure it has attachment points defined for link invariants. And this causes a mutual dependency between documents. If now we summarize the different apparatus methods, we see how markup, in a sense, hinders models' independency and scalability. The location referenced method just embeds app in L. The complexity increases, yet we have no explicit link between variants and text, just like in a paper apparatus. To provide this link, the parallel segmentation method splits our verse into 3 chunks, and this forces the schema to be more lax, even recursive, because we have seen app can be either the child or the parent of L. And we may need to recur to hacks to segment our text as needed. Finally, the double endpoint attached method, which is the most powerful, uses 2 distinct documents, as ultimately the only way of avoiding clashes between 2 trees is separating them. Yet, this separation makes them overtly complex. Keeping them in sync can be a pain, and it still requires touching the text to insert anchors to be used in the dependent document. So, in all these methods, adding metadata implies altering the text structure to merge data about its tradition in it. And this happens whenever adding a new structure to the unique one. And of course, it's in the nature of markup. Yet, in some cases, issues grow with complexity. And complexity can grow for a number of reasons. First of all, subdocuments are intrinsically complex, and that's the case of inscriptions, where even a few words can be connected to a huge quantity of metadata coming from various scholarly fields. For instance, we might want to connect prosopographic data to this name and add a paleographic description for the chrismon, explain a comment that in Pacem implies an implicit verb like requiescit, provide a linguistic annotation about the Dixit orthography, and again add the Censius age to his prosopographic profile, convert the Roman date for the document's chronology, resolve the epigraphical abbreviation, etc. And all these are metatextual data. We will then have also extra textual data, like, for instance, archaeological context, excavation data, physical description, etc. So even with a few words, our annotation possibilities are virtually endless. And issues here can arise very quickly, even when dealing with trivial metadata. Take, for instance, these 2 words in an inscription. On one side, we have the word que, which is the product of a linguistic evolution. As you know, I first becomes I in the 2nd century BC and later E, but very early in plural Latin. And that's the underlying linguistic data. On the other side, we have a ligature, which we might want to connect to some specialized classification like that proposed by Manzella. Here we have a connection for EV and an overlap for IT. And here we are hitting the overlap barrier, because overlap, of course, is not allowed in XML. Yet, if we were to tag both que and EV, these tags would overlap. And also, besides intrinsically complex documents like inscriptions, another relatively recent complexity scenario is given by the systematic application of advanced analysis tools on text. And this happens, for instance, with post-tagging in morphology, tree tagging in syntax, automatic metrics analysis, etc. And the result of such specialized analysis tools would be encoded in multiple structures, often not compatible, producing a more and more complex schema, eventually hitting the overlap barrier. So, either because of the nature of our documents or because of the systematic collection of specialized data on them, we end up with a lot of trees. We have seen our text tree, the comments, the protopography, the paleography, the linguistics, the epigraphy, the chronology, the archaeology, post-tagging, tree-tagging. Houston, we have a forest here. So this equation may lead to overly complex markup, a lax and polysemic scheme, and a poor scalability and user experience. And this is a consequence of the book paradigm, and I'd like to propose a radical shift, fully reversing our hierarchy, at least for these cases where complex keeps growing and becomes an issue. We have seen our traditional book model, which is text-centric, and metatextual and extratextual data are both laid on the text structure, and multiple semantically different structures are merged into the unique tree. Now, let's try to free data from their text cage. In this model, data are our start points, each with its own model, independently designed and stored. And text here is a datum like any other, rather than the unique data-bearing structure. So metatextual data are segregated and independent from text, and we have limitless extratextual data. So which are our data? Virtually anything. We want to provide a reusable system for editing any structured content and any mixture of them, for instance, inscriptions, literary texts, papyri, archaeological artifacts, etc. And this variety of content implies that we must provide open modeling, that is, scholars must be free to design and add their own independent models according to their subjects and purposes. And also, we are in favor of composable modeling because most models are not monolithic, but rather they are parts of their inner structures, often recur in many other models. For instance, take a datation. Virtually any of the sample records may have it, from inscriptions to a series of dictionary lemmata. And datation may be much more than a simple number. Here, for instance, you find a list of various textual expressions of chronological nuances. And to preserve this rich variety, we must design an appropriate model for our datations. And given its relative complexity, it would be wise to reuse that model wherever such datations are used. So we could define, for instance, this model starting from the timeline, and by setting a single point on it, we cover expressions like those highlighted in yellow. If we had another point, we define an interval which covers yet other expressions. The point might be somewhere before another one as a terminus ante, or somewhere after it as a terminus post. And so here is our model. It has either 0 points when it's unknown, or just 1 or 2 points. And each point is an object with its own schema. And for instance, take this real-world expression. Its first point has a here value of minus 367, spanning across true Gregorian years, and is dubious. And its second point has an approximate year value of 150, with a hint about its definition. And all this is our datation model, and it has a corresponding datation user interface for editing it. And the datation model in the system becomes a building block, and it gets aggregated to others to form a higher order model. So here, all our data are composed by such building blocks. And in Cadmos, we essentially have 2 blocks, items and parts. The item is an empty container corresponding to the record, whose model is the sum of the parts it includes. You can think as of an item like an empty box, which gets filled with parts. And each part is an atomic, independent, and reusable data model, like the above datation. And parts may indifferently represent textual, extra-textual, or metatextual data. So we can put any type of object, that is, any part, in any box, that is, in any item, and adding a new object does not affect the others in the box. For instance, we may have an inscription which has a part text for the text model, a part date, and a part size. And then we have a literal text which shares the part text with the inscription and also the part date, but has no part size. Or maybe we have a coin which has the date, the text, and the size. Or maybe a theatrical mask which just has the date and the size, but has no text. In any case, each part has its own data model and editing user interface, and both of them are reused across the system. And for metatext, metatextual data is a part too, thus it's an object rather than markup. And each metatextual data type corresponds to a part type with its own model, and it can be apparatus, comment, paragraphic description, etc. So let us recall the overlap behavior sample just shown before for QUE and EV. In this architecture, there is no overlap, and we rather project metadata on several distinct layers stacked on top of a base text. So our sample has two layers of metatextual data, which are the orthography and paleography parts. And both parts refer to the same base text, which is yet another part. And all these parts are inside the same box, that is our item, the inscription. So the inscription has a part text, which is the base text part, and has an orthography part, which represents the layer stacked on top of the base text holding orthographical data. And then the same happens for paleography and any other layer we may want to stack on the text. Each text annotation on one of these layers corresponds to what I call a fragment. A fragment is just a data model and has its own model and its own corresponding user interface. So for instance, here we can annotate the standard orthography for Christie and QUE in the orthography layer, which has 3 fragments in it, one for each word. And each layer contains a specific type of fragments. We have just seen the orthography layer, here in yellow. We could add another layer to resolve abbreviations with 7 fragments in it, and maybe another one to host the paleographic descriptions of some peculiar letters with 12 fragments in it. So if we recall our complexity sample, here is how we could model it into parts. We first have our base text part, which is the text as it appears on the stone. Then we have a prosopographic part, a paleographic part, a comments layer part with 2 fragments in this case, an orthography layer part, a chronology layer part, an abbreviations layer part. So we have 7 parts into one single item. And this makes up a very simple architecture where all records, textual or not, are just items, and all items are equal because they are just boxes and include any number of parts. And each part, whether textual or not, has its own model and user interface. For instance, this is the model emerging from the sum of all the parts representing data in our inscription. If instead we have a theatrical mask, we drop all the non-applicable parts, and the sum of the remaining ones is its new schema. Or let's say we are dealing with critical text. In this case, we drop the physical description and, for instance, add apparatus, comment, and text. So, in a sense, Cadmus items are the aggregations of data models, parts, and fragments, and the Cadmus editor is the aggregation of their user interfaces. This lets us escape from the markup cage, because no markup means no overlap barrier, and no more mutually dependent models or mingled into a single tree, eventually with hacks and compromises. No more changes to existing data when we are adding new data, and no more unpredictable structures requiring analysis and reinventing ad hoc software each time we must process them in a specific way. And no more editing dependent on a local and single user document files. And as we are now dealing with a true database with a highly structured data, we also have the possibility of real-time indexing and easy compliance with linked open data exports. And the part being an open model in Cadmus, it's the only entity to have competence of its data and thus capable of indexing them. So in Cadmus, each open model, that is, each part and each fragment, can expose so-called data pins from its own content. And data pin is just a name-value pair of whatever type. And it can be used to provide indexing, load triples, etc. And notice that indexing here covers all the aspects of a data model, whatever its complexity. So for instance, let us consider our Bixit sample in the orthography layer we have seen before. The orthography layer not only registers the standard orthography, it can also add all the operations which describe the transition from one form to the other, in the way required to account for the underlying linguistic phenomenon. In this case, we just have a replacement accounting for the hypercorrection due to the spirantization of B. But let's take, for instance, another case like pena. Here, we want to best represent the monophthongization. So we don't describe the operation in terms of an insert, but rather in terms of a replace, because this better encodes the linguistic phenomenon by which oe gets written as e. And finally, here is a more complex case, accesso for arcesso. Here, three operations are joined together. The starting point is the mobility of liquids by which R is moved earlier in the word. And this triggers the degemination of C and the complementary gemination of S, which preserves the prosodical profile of the word after the initial consonantic change. Now, all this evolution is summarized by these three operations, which in turn underlie the non-standard orthography registered in the layer. And with such a highly structured model, it's easy to automatically build a detailed index of linguistic phenomena by just collecting the data pins from the orthography layer. And now imagine this collection process multiplied for the number of layers of any type we might ever want to stack on the same text. As we have seen, we have no limits here because adding new layers does not affect existing data nor their models. And this is just one step away from exporting a subset of this data into LOT. Finally, as I've mentioned linked open data, I should add that the system allows for a completely customizable set of taxonomies. And wherever a user interface component needs a set of predefined values, it draws them from a common taxonomy set, what I call a thesaurus, either flat or hierarchical and fully localizable. And taxonomies like models are defined in a profile used to see the Cadmus database. And we can derive them from existing LOT vocabularies or just create our own. For instance, here is a very simple thesaurus representing a set of languages. A keywords part editor, the keyword part assigns any number of multiple language keywords to an item, uses this thesaurus to present the languages in a drop-down list for user selection. And of course, that's a trivial sample, but much more complex taxonomies, eventually hierarchical, can be used for any parts or fragments. And this makes the user interface much easier, prevents potential editing errors, and allows our data to be modeled in compliance with lot vocabularies from the very beginning. And at this point, I hope to have sketched the system architecture enough. And let us try to recap. The items are empty boxes, higher order models, which are dynamically defined by the sum of their parts. And we can put whatever part we want inside them. A part is just a data model of whatever type. Some of these parts have nothing to do with text, others represent text, and others represent layers stacked on top of the text. On each layer, we place any number of fragments, each linked to a specific portion of the base text. And parts and fragments are our data models and building blocks. And they are an open set. We can add any of them at any time, just like tossing a new object in a box. Finally, all these open models expose data pins for indexing. And that's our backend. In the front end, we have a parallel set of editors for each part and fragment type. And a thin web API surface connects these two layers. And finally, from the database, we can easily publish data either as a traditional TEI document or as a web application or a web API, load endpoints, or whatever else for both human and machine consumption. So, to be more concrete, I'll show you some shots of the editing experience. But first, let me emphasize how radically different will the user experience be in this case, because here we work with a centralized repository using a database, robust and scalable. And in XML, instead, usually editing is more fragile as it relies on locally edited files. The database allows, of course, real-time indexing and search, while the indexing infrastructure is outside the realm of XML files. And with a database, it's easy to allow concurrent and remote editing via a web frontend connected to it through API endpoints. Also, we provide auditing and editing history. In XML, instead, we usually have a single user editing a local file. And this also grants real-time and granular validation and an easy graphical user interface requiring minimal training. So, how does it look in the front end? Let's start from the items list. We can see it here. We can filter, edit, or delete the items. And when editing an item, we can enter all its metadata, like, for instance, title, description, facet. The facet is the definition of all the parts which must or can appear in it. Group and flags. Flags are a set of labels we can stick to items, each with an arbitrary meaning. For instance, a specific flag might be attached to those items marked for a later revision. And each item has its parts, here grouped by families, and we can, of course, add a new part by just selecting its type and clicking, or edit a part or delete it. And whenever we edit a part, its own user interface opens. And here you can visually realize the dynamic and composable nature of both data modeling and editing user interfaces. Because each part type and each fragment type has its own model and its own user interface. For instance, we can pick datation with the model discussed before. Points, year value, modifiers, and hint. We can fill these controls, or we can just type the corresponding textual expression at once and let the user interface parse it, filling the appropriate visual controls for us. Or we may want to edit the text part. In this case, it's very simple because we just have to enter an optional citation and type the plain text in the box. Then we have the items layer parts, which accounts for metadata, metatextual data, with a list of all the layers which exist and all the layers we could add. And here too, a click is all what we require to add, edit, or delete a layer part. And as for any other part, adding a layer does not affect in any way the existing data and their models. And as for any part, we just have to click to edit a layer. And the layer shows the base text highlighted wherever a fragment is linked. From here, we can edit, delete, or add a fragment for the current text selection. Thus, adding metatextual data here is as simple as selecting text and clicking a button. And just like for parts, when editing a fragment, its own user interface appears. It shows the base text with the corresponding selection and its specific interface. Here, the apparatus has a list of entries, something richer than simple variants, which we can edit, move, or delete. And from that list, we can edit an entry like this, which is a replacement variant addressed them for Silvestre, which has no witnesses but two authors with their notes. And they are all picked from a human-readable list derived from our thesauri. And now let's compare this with the traditional editing experience, where we manually type all the XML code in two different documents, one for the text and another dependent document for the apparatus. In any editing operation, we must keep them in sync, and we also have to link each variant to its text and any other data scattered across branches via unique non-human-friendly identifiers. Now, even if we want to use Cadmus just to produce a TI export, this would provide a much better user experience. But I hope that my discussion may have given at least some hints about the potential of a radically different mental model independently from its implementation, at least for some types of very complex and specific documents. So in conclusion, I won't ask you which do you like the best, but rather thank you for your patience. Thank you, that's all. We open the discussion now.
Thank you very much, Daniele. So this was a very impressive and complex topic to our audience, and I'm sure there will be a lot of questions. So we decided to pose your questions, please, in the text chat. So there's a text box on your screen in the top right corner, which you can click on and pose your question there. Otherwise, we get a Babylonian experience here, I suppose. So if you have a question, please type your question short, or say you want to say something into this chat, and then we can give you either the word and unmute your microphone, or Daniele is able to respond directly to your question. I'm reading, there's a lot of applause as well in the chat. So Daniele, this is for you. Okay, what about importing TI or other documents? Really, we are just doing this. Can you repeat once again for the audience to the question you are answering? Sorry? Can you repeat the question you are going to answer? Thank you. So Holger was asking about importing TI or other document types, and that's a thing we are starting to do just now, even before Cadmus is ready, because we are using this prototype as a test for editing the TI documents for Musisque de Oque. And so if you go to the GitHub repository of the center, you will find the code for Cadmus, but we also find another project which is right for MQDQ Musisque de Oque, because that's a way of testing this editing environment with true TI-based resources. So in the future, we may want to provide some standardized tools for this import and export, whatever we want to do with the database and this editing system. And okay.
So Roberto Rosselli del Turco is asking, is there a web demo we can play with? And there is a code in the GitHub repository. And if you go to the GitHub repository, you will find also Docker Compose script. So you can just download the Compose script and launch it if you have Docker installed. And you will be able to play with the code and with the running demo, which starts the database layer and fills it with mock data, and then presents you a user interface. You will find the instructions in the website, in the GitHub site. And about the internal organizing of data, there are some technical documents in the GitHub too, but they are still incomplete because the software itself is under development. Anyway, if you want to know something about this, currently I'm using a NoSQL database, specifically MongoDB. And we have a collection for each of the building blocks of Cadmus. So we have an items collection, a parts collection, a thesaurus collection, and so forth. Okay, any other questions?
There was a question by Simone Zenzaro first, in the context of exporting data to TI-XML. How is it managed, the transformation from logical overlapping parts to the needed merge of the transformation?
Yeah, thank you. In this case, of course, it depends on what we may have on output. It may be the case that in the Cadmus database, we have a superset of the data we may want to export into TI. Anyway, the usual approach is providing sort of double end point attached method, that is to detach for instance, the apparatus parts in a separate document and refer to it via IDs, because that's of course much easier for a machine and much complex for a human operator to do this.
Then we have a question by Stephen White. Layer have different granularity of expression, sometimes sub-orthographic. How do you handle this? Steve, if you want to elaborate on this, please put on your microphone, or do you?
Sure, I'm happy to elaborate. What I mean by that is it has very much to do with the overlapping issue, and where sometimes you have, let's say in a syllabolic language, your word boundaries fall in the middle of a graph, of a glyph, and your expressions potentially lie in alignment between the expression of those glyphs or the expression of the word. So it really depends on what you consider to be your base layer. And as I get that, in your case, Danielle, the base layer is the text or the transcription. But there are layers that go beneath that potentially that also have disciplines for analysis. And you group those, put them in boxes that necessarily go below the text layer.
Okay, thank you. That's very interesting. Anyway, I have shown you the text-based layer because it's easier to be presented here. But keep in mind that the text layer is just a part like any other. So we can easily replace this part, which is modeled as a text, with any other part, which can be modeled, for instance, as a collection of items of some sort, which can represent glyphs or any other kind of thing you can consider as the atomic unit of your transcription. So, of course, as you are going to transcribe something, you can choose the model you are best with. So it can be just a set of characters or a set of codes or whatever. Anyway, you can model it as you prefer as a text part, and then connect the layers on this text, which is the text which is different from a string of characters.
We have a question by Joel Calvismaki. Should I read it? It's a longer question. One of your criticism entailed the mechanism used in traditional TI to tether an annotation to the text, inline versus anchor-based. In your Cadmus alternative, we didn't get the opportunity to see what mechanism you are using to tie an annotation to a text fragment. We saw some syntax snippets, such as 1@1, but this was rather cryptic. Can you say more about Cadmus' internal pointing mechanism and how it gets update as either text or annotation change? Daniele.
Okay, that's very interesting, and I think it can be a way to go, but it's something complementary but different. That is, this kind of thing, if I understand well, was a sort of way which is to solve some issues of TI by extension of the markup mechanism, using a different type of markup which can solve the overlap issues and the like. In my case, what I wanted to do is essentially to provide a true database, a collection of data, a graph or connected data, which can be directly used for whatever purpose we want. So maybe I am a scholar which studies history of the language, and I'm just interested in collecting all the cases of maybe spiralization of plosives in Latin. And so this kind of database will allow me to do this right when I enter data, rather than having to first create some sort of text, mark it up in some way, and index it into a database, and then querying the database. So I'm reasoning it more from the IT perspective, that is to provide data and not to have a start point as a text and build data on the text as markup.
Daniele, just a technical question. Can you please stop your presentation? So because everybody's seeing the screen, so then we can see you talking or the person posing the question.
Okay.
If this is sufficient as an answer, please let us know, Joel.
Okay, thank you.
Question by Joele Marozzi. In September 2019.
Yeah, this was the question I've just answered.
Okay. Okay. So I'm not sure if we missed a question in the chat. Otherwise, please feel free to post it again into the chat.
Maybe I skipped something because text scrolls up and I haven't seen anything. So just paste it again if I missed someone.
Right. So we have a question by Simone Zenzaro. As an example, a text A that is the concatenation of text B and C, I imagine that for each text will exist a part describing phenomena. How to handle a phenomenon across B and C?
Sorry?
So the question by Simone Zenzaro.
Yeah.
As an example, a text A that is the concatenation of text B and C. Okay. I imagine that for each text will exist a part describing phenomena, how to handle a phenomenon across B and C. Otherwise, Can you elaborate? You got it?
Okay, it also depends. This is a sort of open model, so it's just up to the scholar to define the models. I can provide a set of predefined parts models and fragment models, but this, of course, does not rule out the fact that every scholar can provide his own parts and fragments for his own purposes. And in this case, we might have to discuss whether it's better to just have one part representing a complex object or several different parts representing a complex object. But that's more a question which refers to data architecture and how we intend to use our data for whatever purpose. So it's how we want to model our data according to our purposes. And of course, this is a decision which has some trade-offs and depends on our purposes and our vision of our data, because every model, of course, is an interpretation of something complex, which is simplified and formalized into some scheme.
I'm not seeing any further question right now. I have a question myself. So you showed a lot of image data, but not as an example in your code. So how does Cadmus work with image data, IIIF maybe? So how to align text with image data and organize a digital archive, for example?
Yeah, this depends on the parts we are planning to insert in it. We may want, for instance, to add Cadmus part to represent the mapping of some kind of information to the regions of an image, like in IIIF. Or we may want even to get a tool which takes a IIIF code and converts it, remodels it into a part, and automatically imports it in a database. And this all depends on the parts we want to know. The beauty of this approach is that that's an open system. So you just have to think about what is better and try to implement this. The idea is to try to collect a number of different parts and fragments in a sort of big repository. And everyone using the system can add their own parts when studying, for instance, specialized issues about some subjects. For instance, if we are going to publish a set of inscriptions, we can just be satisfied with existing parts. But maybe we have a set of scholars which are specialized in prosopography, who provide us with much better modeling for prosopography data. And in this case, they would make their own parts for their purposes and then lend it to us by publishing it in this repository. So the next project having to use prosopographical data will be able to use this shared model rather than each time reinventing the wheel.
Sorry, I always have to switch microphone and then the chat disappears. So that's my struggle here. So we have a further deepening question by Simone Zenzaro. This is maybe easy and briefly to answer, and then a question by Stephen White. So Simone asks, does this mean that we should know a priori the phenomena of the text? So like knowing the total lemma encompassing all the readings in a parallel segmentation method? I hope not.
No, not of course. We just have to know how we want to model our data. And this, of course, is the job of a scholar. But as scholars, we often find ourselves in train of the research, in changing our minds and maybe change the model and add new subtypes to it, or just model it differently because we have sorted out that this works better with our data. So in this case, we just start with a hypothesis that is a part which maybe represents, at best, our idea of some phenomenon. And then if we realize later that this is not enough for us, we can just change it. And this means we can just add a new part to represent a specific kind of datum it was not present before, or even change the existing part and remodel the data as we want. The essence of the system is trying to be as open as possible. So it's a sort of empty box we must fill with our disciplines and our knowledge and our skills.
So I hope that answers the question. Simone is happy with your answer. Thank you. The other question is from Steve. I don't know if you know the READ environment he has been developing with colleagues from Sydney University, if I'm not mistaken. And his question is, how does your model and tools compare to the READ environment? So if you are able to give an answer without elaborating too much on the specificities of the READ environment. So, yeah.
Okay. As far as I know about the READ environment, it's something which stays a bit before the Cadmus system. That is, it provides the essential transcription of a text into something which is digital and is very well modeled and structured, so that if I had to start some project about...
Actually, that's a different READ system. There are two READs, READ Progress, which is Tarbucus, and then there is READ with LMU and UCID. That's been a 6-year project. And it basically does LODLAM. It has a graph model, but in a Postgres database. Okay. And it does all the layering and various different layerings like you suggest. So that's why I asked. Sorry to barge in, but I had a question about the data. Actually, a different question about the changing of model. Because the changing of model for existing data, especially in a large corpus, requires the ability to do merging of items or model data types. And separation, so, and sometimes morphing. So how do you view that? It's not just simply adding a new object or getting rid of or adding a property or removing a property. It's a lot of times a merge and a separation process.
Mm-hmm. Okay, in general, I see the thing as a higher order model. That is, in Cadmus, an item, that is a record, is just the sum of its parts. And so the change in model usually is not changing a part, but is adding a new part to the set. And this part may have the function of maybe connecting to different parts, or maybe just to add a new kind of data to the item itself.
Thank you.
We have another question from Paolo Monella. So a question on sustainability and long-term data preservation, interchange, interoperability. So if Paolo creates a DI XML-based edition, the data is openly readably files, so XML files, that will be read in 10 years. If I do it in Cadmus, I have a database. Can I export it or all of it and port it to other projects for interchange? So that's an important question.
Yeah, of course, that's one of the benefits of XML, that is to be something which can be considered also a sort of archiving the tool for future, because it's just plain text, so it's not an issue for everyone. But anyway, first of all, that's a database, but a database can be dumped into plain text if you want. In this case, the database it uses MongoDB, which is JSON based. So we might want just to dump the whole database into a long text file, which reports each of these parts and items as a JSON object. But apart from this, Cadmos is more content production tool. So it aims to create a database, and this database then is the basis for publishing. And publishing must be taken in a wider sense. So we are not meant only to provide, for instance, a website where we publish a web application which provides user with query and other typical user experiences, but also, for instance, exporting data, and maybe we might just want to provide a RESTful API or a load endpoint, or even provide a full TI document as an export. So maybe the TI document will not cover all the data which are inside the database, because some data maybe are not very capable to be fitted into the XML document, but in theory, whatever we have in the database, we can publish in another form if we are concerned with preserving it. And it's important to emphasize the fact that I'm not against TI. That's just a way, maybe also for producing TI, where we have difficulties, we have issues in doing it with traditional methods. And we often find ourselves in having some typical requirements in editing. For instance, we wanted to edit data in a web-centric manner with a lot of users working at the same moment on the same data. And all this kind of infrastructure is not available usually for TI-based files because they are local system files.
Further questions? Are you happy, Paolo? Or...
Yes, I am.
Okay. I don't see any further questions in the chat, so did we miss someone? Then please post it once more into the chat so we don't miss it. Yeah, so bravo.
Thank you.
Federico, how do you manage discontinuous annotations?
Okay. Discontinuous annotations is a thing we have faced a few weeks ago when building the import tool for the Musisco Edeoque, because we have found that in some cases we may have an apparatus entry which refers to two different locations in the text which are not contiguous. And in this case, it's just a fact of modeling. And I have solved it by just providing a group ID as a property of every fragment in the apparatus model. Fragments are the annotations linked to each specific region of the text. So if we want to group two different annotations scattered across the text in different regions, we just have to provide a common shared group ID to both the fragments, and these will be considered as a unit, as a semantic unit, even if they are archived as two distinct fragments in a layer part.
Okay. I have a question. I'm fascinated. I'm fascinated by your approach, and it's very, very convincing to me. I'm very much trained and formed via some noise. Rita Maria, can you mute your microphone? What did you want to say? So if we consider or if we design the digital edition, I'm a textual scholar who wants to create digital editions as a resource that brings together linked open data. So as a aggregator of data that is available from various resources. So Cadmus is a kind of aggregator, but it stores the data within Cadmus, so produces data and provides it, makes it accessible for others. But how does Cadmus then relate to the world of linked open data? Maybe just to have a more practical understanding how this interacts with data that is not within Cadmus.
Yeah. We have maybe two types of linking with linked open data. One is before, in a sense, Cadmus. That is, we may want to provide a set of tools which allow us to select or pick an existing load vocabulary and import it directly in Cadmus as a set of thesauri for our editing. And on the other side, as publication, we are not meant to directly create a triple set. We are rather modeling our database within our purposes as parts and items. And then we may let each part and fragment provide its own data pins, as I called it before. And these data pins will be the basis for exporting a subset of the data as load data, because usually we are not going to export the whole database as linked open data, but just a subsection of it, which is useful for us and for the purposes we are working to.
Thank you. We have 3 more questions, and then I think if there are no further urgent questions, we can close the discussion. There is the question from Stephen. Is the group ID unique? Yes or no?
Okay, I answered in the chat because I didn't know if this was of common interest, but the group ID is unique only within the scope of the layer. So between among all the fragments of that layer part, the group ID is unique, but only inside the scope, not outside it.
And then we have the question from Angelo. What kind of textual analysis features Cadmus is able to provide?
Depends. I mean, now it's just being developed as a content creation system, and a part of this system is about indexing, but we are free as scholars to provide our own indexing, and we might want to model this indexing, right, to answer this kind of requirements. But of course, it depends on our purposes. So in the sample I just sketched before about the orthography layer, we could just be satisfied in annotating, for instance, that Vixit is the form for Vixit, or we might go further and explain why they wrote Vixit instead of Vixit. And if we do it in some way like the one I have sketched, this allows us, for instance, to create a linguistic database, a database of linguistic phenomena, which we can query with, for instance, questions like, give me all the cases where we find the Esperantization of B in inscriptions between the 3rd and the 1st century BC. And so it all depends on our purposes, and the idea is just to provide a basis and then build on it, because Cadmus has been designed to be an open system and open to expansion. And so we can provide a base and then let scholars specialized in different fields provide their own skills in terms of Cadmus parts, so that we can all share the knowledge and build a better edition.
Okay. Any further questions for Daniele? Urgent questions? Otherwise, I would really like to thank you very much, Daniele, for this impressive presentation and this very good discussion. I think this was an excellent start for our virtual life, academic life, and our online seminar series, which will continue for the next weeks and months, probably. So I see a lot of nice messages in the chat, all for you, Daniele. Thank you very much. So we will share your slides on our GitHub account, which is interlinked from our website and also will be interlinked from our YouTube channel and vice versa. The presentation with all your explanations and the discussion will be put online on YouTube. The code is all accessible also from GitHub. Anything else you want to add for information to the audience, Daniele?
Okay, at this moment the code is a bit harsh and it's in an alpha state, but you can find 3 different projects in the GitHub repository, and each of them has a piece of documentation. Most of the conceptual documentation you will find in the core project, which is the project which feeds the backend. So it's named Cadmus Core. Then we have another project which is named Cadmus API, which is just the API layer. And the front end is the Cadmus Web project, which is an Angular application. But the real meat is in the Cadmus Core.
Okay.
Okay, I just inserting my email in the chat because someone was asking for it.
Otherwise, everyone will find all information, contact details, and upcoming events, further seminars and other events on the website of the Venice Center for Digital and Public Humanities. We will post upcoming events and information on all our social media, so on Twitter and on the many mailing lists. Yeah, please, if you are interested in the work and the research of the center and the department, you are very much invited to subscribe either as a member if you're part of the University of Ca' Foscari, or as an affiliated member for external colleagues. On the website you can subscribe, and then you will get regularly a newsletter that inform you about upcoming events and all the information that we have. So that's something you can do to make sure you don't miss the next events. So there's Stefano to say.
Yeah, just wanted to add they can also follow our Twitter account. That's just another possibility.
Absolutely. So we are very busy on Twitter and we share this account. So everything that happens will be visible on Twitter. You can go also backwards, so it's like the record of our activities. Okay. So thank you once more, Daniele, and thank you everyone for attending this online seminar. I hope you liked it and you are able to work on this on the new input. Feedback is very much welcome, and yeah, I wish everyone to stay healthy and to get through this difficult time. So this will take another while, unfortunately, but yeah, this is one way to carry on and to bridge the social distance that we are all obliged to maintain. And yeah, best of luck. See you, I hope, next week when Rodolfo Del Monte will present on poetry and computer speech. analyzing and reading Elizabethan and modern poets with Sparsa, and then the week after, Sara Tonelli on current studies on cyberbullying and Islamophobia. And yeah, hope to welcome you back then next week. And thank you for the technical support and all the preparation of our task force for the seminar series, Federico, Tiziana, Linda, and Paolo. Okay. And ci saluta anche Giovanella Crescita, il direttore of the department. So thank you very much, everybody. And bye-bye.
Bye. Bye. Thank you.